recordings. Plot the corresponding reference circle for each of the following simple harmonic motions. Indicate the initial t is equal to 0 position of the particle, radius of the circle, and the angular speed of the rotating particle. So that means omega is asked, radius is to be shown, and then the starting point is to be shown, and then we should also include the direction of the rotation. For simplicity, the sense of rotation may be fixed to be anti-clockwise in every case. So they're asking you to keep it as anti-clockwise all over. So let's try this. So my simple logic says that if I'm taking a circle like this, sine means I should be starting from the center point. So this is your extreme point. So this is your center point. So either I can start from here or I can start from here. So listen carefully. Both possibilities are correct. Okay, either you can start from here or from here. And then it says x is equal to minus 2 sine this thing. So that means the sine curve will look something like this. But the minus sine curve will look something like this. That means it's not this one, it is this one. Okay. Cos means it will start like this. Minus cos means it will start like this. So it means since you have sine, I have to choose between these two things. And since it is minus, I have to choose this one. So it's not this, it's not this. Some of the easy things is radius is going to be 2, right? Because the amplitude is equal to the radius. So that means this is 2 centimeters. And this is omega t. Omega t means omega is your 3. So in place of omega, I have 3t. So that means omega is your angular speed. That means that is your omega. Okay. Minus means, listen carefully, since it is a minus, I am actually going in the negative displacement. I would take this as positive displacement, this as negative displacement. So since I'm going in the negative, right? They said take the sense of rotation as anti-clockwise. So anti-clockwise means it's going this way. So that means since it is going negative, right? Should I start from here or should I start from here? What do you think? If I start from here, anti-clockwise means it will go this way. So it will go to the positive direction. But I want to go in the negative direction. So that means I have to start from here. Everyone making sense or not?
Yes, sir.
Mithun?
Yes, sir.
If I start from here, what is the problem? It will go in the positive direction. But I want to go in the negative direction. So only if I start from here for the given anti-clockwise direction, it will go this way. Okay. So that means this is my starting position. T is equal to 0. So I found T is equal to 0, I found omega, I found the radius. That's all. So that's your answer. So you see, if you draw this graphs, this will help you, know whether I'm going in the negative direction or the positive direction. I forgot one more thing. You see, this is pi by 3. So what this means is it's not exactly starting from this location, right? So if it was just 3t without this pi by 3, then I would have said this is my starting point. Okay, so that means this is wrong. So since it is plus pi by 3, what it means is the starting point is not here, the starting point is somewhere here. That means compared to this position, which is 3t, this is your pi by 3. So this is called the initial phase. So what this means is instead of starting here, you are starting from here, which means the graph is not going to look like this. The graph is going to look something like this. So it means this part is already hidden here, or in other words, the easy method is I can shift the origin somewhere here. So it means it's already starting from here. Why? Because the projection of the shadow will be in the negative direction. You see, this is already in the negative direction. Pi by 3 means 60 degree. Any questions? Do you understand the mistake I did? There is an initial phase. That means you have to show that the starting point is slightly here. It's not here. Okay, so similarly, I want you to do this as a homework, double check your answers. Okay, I already given you all the methods here. If you want cos, right, it will be starting from the extreme position. If it is sine, you have to start from either here or here. Again, this is cos means either here or here. For example, if you're starting from here, I will do one more thing. Okay, one more problem here, and then I will leave these two things as homework. So cos means I have to start from this extreme position. Should I choose this one or should I choose this one? Well, it looks like this is a positive displacement, which means minus t. So that means minus t is still positive. So we are going in the anti-clockwise direction. So either you are starting from here or you are starting from here. So since you are moving in the positive direction, I think I would go with this, which means this is the center. So the projection will be shown as though it is coming towards the center. Okay. So it means it's coming towards the center. So the amplitude here is 1. Okay, so the radius is going to be 1. And then omega t means omega in front of t, you have omega is equal to 1. So it means omega is equal to 1. The starting point is a difficult one. Okay, these two things are easy to find. Starting point, since it is cos, I'm thinking either it has to start from here or here. But if you start from here, the moment you start t is equal to 1, t is equal to 2, the values will actually start decreasing. So this will correspond to this location. This will correspond to this location. Why? Because here the projection will be here. So it's already in the positive direction. And as you increase the time, it's going to come down. So which means it's going to come down. Okay. If you're not able to combine this and this, it's going to be confusing. So I'm just saying that the extreme position is here. You see the extreme position is here. And then it is coming down here. So it's going towards 0. Here also it's going towards 0. And then it will be going in the negative direction. You see it's going in the negative direction. And then it will be coming back here, which means it's coming back here. Suppose if you take this graph, then you have to start from here. Why? Because it's already in the negative direction. And then you are going towards the 0. I'm just wondering. So now I said that this is my starting point. Pi by 6 is the initial minus t plus pi by 6. So plus pi by 6 means minus t plus pi by 6. So since it is plus pi by 6, location will be taken somewhere here. We said anti-clockwise direction. So then there is a minus here. So it is minus. Listen carefully. If I say cos theta, right? Theta is in the positive direction. If I say cos minus theta, it means it's going in the opposite direction. So that means instead of the arrow going this way, I think even though here it says anti-clockwise, here I think because of the minus t, I think you should take it as clockwise because it's in the opposite direction, minus theta. Then since it is plus pi by 6, you have to take it in the positive direction. So this side is positive direction. So very confusing. So listen carefully. In your protractor, right? If you are going like this will be taken as positive theta. If you are going like this will be taken as negative theta. So anti-clockwise is positive, counterclockwise is positive, clockwise is negative. Okay. This is a bit confusing because you would think that clockwise is positive, but in our usual protractor, right, we take this as positive and this as negative. Everyone agree with that? This is what you will be doing in your maths. Is that correct? Nobody agrees?
Sir, didn't get it, so can you tell again?
In your protractor, in your maths, if I say draw a line for 30 degrees, what will you do? You will draw a line like this, and you will bring the protractor, and you will mark this point here, and then you will take a scale and you will draw like this. Do you agree?
Yes, sir.
So that means why you did not go this way? Why did you go this way? Because 30-degree means usually the convention is we will take this side, right?
Yes, sir.
If I had said minus 30, then you should have taken, you should have rotated the protractor like this. And then you should have taken the arrow here. And then you should have taken this. Does that make sense?
Yes, sir.
That's what I said. So generally, our brains will work with numbers, not work with x, y, or theta. So I think in that case, since it is minus t, I should be taking it this way instead of taking anti-clockwise. I should be taking clockwise. And since it is plus pi by 6, I should be taking this as my t is equal to 0 point. So this angle is your initial phase pi. Pi by 6 means 30 degree. So that's your initial phase. Okay. Sine cos, I already told you. Okay, sine means you should take it from the center point, either this or this. Cos means either you have to take this or this. Okay, so and then look for the omega and initial phase. Okay, C and D, I'm going to leave it as homework. Try it. If you have any difficulties, we'll discuss it in the next class. Ashwant, are you okay or finding it difficult?
Sir?
Are you following everything or are you finding
Sir,
something
yes, sir.
difficult?
Sir, no,
Following. Okay. Yes and no, but I don't know which one. Yes for what? Understanding.
sir, yes, sir, I understood, sir, and I'm following with this.
Okay. If you have difficulty online, you can come over here also. Okay, I don't have any issues. You can come to the center.
Okay, sir.
The others, I think you are pretty much attending only online. Okay, let's go to the question over here. Okay, I think there are two parts. So let's read through this. I think the first one is easier. Maybe this one you need some background knowledge. Let's look into this. Figure 14.26 shows a spring of force constant K clamped rigidly at one end and a mass M attached to its free end. The force F applied at the free end stretches the spring. Figure 14.26 shows the same spring with both ends free and attached to a mass M at either end. Each end of the spring is stretched by the same force M. What is the maximum extension of the spring in the two cases? Okay. Maximum extension of the spring in two cases. F is equal to kx, I know. So k index is the extension. Any other information given for me? Let's see another given information. Case which this force which are applying. The mass in figure A and the two masses are released. What is the period of oscillation in each case? Okay, I think in this first case, F is equal to Kx. So they're asking to find the maximum extension of the spring. So that means I want to find the x. X is the extension. So x is equal to F by K. What does that mean? If F is fixed, depending upon the spring, right? The spring can be very light, which means if it is very loose, you can have maximum extension. If the spring is very tight, even though you're applying a lot of force, it will not move much. Are you able to imagine what I'm saying? Okay, so whether the spring is tight or loose, that is what the K tells you. So if the K value is higher, then it is very tight spring. If the K value is lower, then it is a loose spring. So it means as you keep on increasing the force, the extension will also increase. So that's your first answer. The mass in figure A and the two masses in figure B are released. What is the period of the oscillation in each case? Well, we studied a formula omega is equal to square root of K by M. So if the mass increases, omega will decrease. If the omega decreases, the time period will increase. So omega is equal to 2 pi by t. So when this increases, what will happen is this will decrease, whereas the time period will increase. Okay, meaning it will move very slowly. Okay, I have some good, demonstrations in the lab. Okay, But unfortunately, folks missed all these things. So now when you change the mass, you can show that the time period changes. So time period is what is asked. So T is equal to 2 pi by omega. 2 pi by square root of m by k. That means as mass increases, the time period will also increase, meaning it will start moving slowly. Okay. For direct formula application, nothing very difficult here. Okay, so this is, this is something which you already studied. This is where you will need some help. So instead of a wall, rigid wall, we have two masses in either case. One way of doing this problem is, I can assume that this spring will be, fixed at the center. Okay, a bit confusing, so listen carefully. So if I assume that the spring is fixed in the center, so this is kind of moving this way and this is kind of moving back and forth this way. So whenever you assume that the spring is broken into two pieces, the spring will become stiffer. So if I say the spring is becoming stiffer, the K value will actually decrease. Sorry, the K value will increase. That means that this part of the spring will have 2K, this part of the spring will have 2K. So if I consider the first part, F is equal to Kx is the usual formula. So if I'm looking for the maximum extension of the spring in two cases, that means the maximum extension for this part of the spring will be, I'm applying a force this way, so F is applied here. K is, instead of K, it is 2K now. And this is the extension X1 on this side. Similarly, the same thing will happen on this side also. So if I want the extension here, F by 2K. However, there will be some extension on this side also. So it means the total extension. The total extension will be X1 plus X2. Which means F by 2K plus F by 2K. 1 by 2 plus 1 by 2 will become 1. So which means it will become F by K. So what this means is, in this case and in this case, the extension is going to be the same. Any questions? Any doubts? Anything not making sense? Please open your mouth. So B part would be time period. So time period is 2 pi by omega. Omega is equal to square root by K. Square root of K by M. So K, I told you, for one of the sides, it will be 2K. This might be slightly confusing for you, but I can explain it one more time. So if you take a spring, if I attach it with another spring, total K will become half. Suppose this was K and this was K. The spring, when you attach one spring with another, what will happen is it will become even more looser. Okay, when I say looser, it's like less stiffness. Loose means less stiffness. Since the stiffness is reduced, right? You would take it as K by 2. This is something like your series connection, parallel connection of resistance. Okay. So in this case, you would take it as, I can show you where you have these formulas. Yeah, so we have to go to page number 37 to look for these formulas. So in this case, if you put two springs one after the other, it's something like series connection. So what will happen is you have to use a formula, something like a parallel connection in resistance. 1 by K is equal to 1 by K1 plus 1 by K2. So since in this case I will be getting 1 by K plus 1 by K, it will become 2 by K, and when you take the reciprocal, it will become K by 2. So this particular example, it will become K by 2. But suppose if you had one spring here and then another spring here connecting with the mass like this, then this is like a parallel connection. In this case, what will happen is the stiffness will increase. Now, if you try to press this, it will become more difficult. Okay, so that means more stiffness. So more stiffness means if this was K and this was K, the total will become 2K. Why? Because the simple formula is K1 plus K2 will be your K effective. So it means K plus K will become 2K. So coming back to this problem, why did I say this becomes 2K? Because the total thing is K. So this is something like series connection. So when you connect it in series connection, the stiffness will reduce. When you break this, the stiffness will actually increase. Okay. So in other words, 2K is one part of the spring, 2K is another part of the spring. So totally, only when you put 2K, 2K divided by 2, 2 cancels, so I'll be getting the K. So that's why this is written as 2K. So this is in the formula. So omega here can be written as 2K by M, because I'm talking about on one side. The time period is equal to 2 pi by omega. So 2 pi into omega is M by root of 2. That's all. So that is for 14.13. So take it down. Anybody not following anything? Anybody, if you don't follow this, please let me know. I can explain one more time. Only if you understand this, these things will make sense. After this is just a formula. Okay, copied. Can I go to the next one?
Yes, sir.
Again, I'm doing the easy ones first, okay, so that you will feel a little more comfortable. And for your school exams also, I would say, first of all, you should be thorough with the easy ones and then go to the difficult ones. By that way, you can attend definitely they will ask you some easy questions and then some difficult questions. So for your school exams, I would say if you are thorough with the textbook problems, I'm sure you'll be comfortable. Because you can talk with your school teachers also. But generally, in my opinion, in 12th standard, you have to do a lot of other problems outside the textbook. For 11th standard, the textbook itself is having a lot of difficult problems, so you can pretty much solve all these things. That itself will give you a good practice. Okay. Mostly they will take the questions only from here. And even if you find some questions outside the textbook, it will be of the same method. Maybe they just change the numbers. The piston in the cylinder head of a locomotive has a stroke twice the amplitude of 1 meter. If the piston moves with simple harmonic motion, with an angular frequency of 200 radians per minute, what is its maximum speed? Okay, very simple. So what we are talking about here is y is equal to a sine omega t and dy by dt differentiation. He said velocity. So velocity is what is asked, maximum speed. He said it is a omega cos omega t. We also said that if I keep the omega outside, if I replace this with square root of 1 minus sine square, so we said this a will go inside and it will become a squared minus a into sine omega t will become y, so it will become y squared. So go back and study your derivations, right? This is what we did. Again, I'm making a mistake. They asked you to find only the maximum speed, so I don't have to worry about these things. What is the maximum speed? Whatever is in front of this, that is your maximum speed. That means I can simply write it as V max is equal to A into omega. So amplitude twice the amplitude, which means 1 meter is twice the amplitude. So twice the amplitude is equal to 1 meter. That means amplitude is equal to 1 by 2 meter. Omega is, they said angular frequency is 200 radians per minute. If I want it in SI units, 1 minute is equal to 60 seconds. So that means amplitude is 0.5, which is 1 by 2. Omega is 200 by 60. So one of the zeros will cancel. 2 will cancel. So 10 by 6, which is 5 by 3. So it's moving at a speed of 1.66 meter per second. Very easy one, nothing very difficult here. So if you have any doubts, please raise it. Acceleration due to gravity on the surface of moon is 1.7 meter per second square. What is the time period of a simple pendulum on the surface of moon if its time period on the surface of the earth is 3.5 seconds? It's very simple. So the time period is equal to 2 pi by omega. So we found it as 2 pi square root of L by G. Okay. So even if you don't know this, you have to remember this. Okay. So you have to. So go back and study the derivation. We did this. Okay. So as the length increases, the time period will increase. We talked about this. As the gravity increases, the time period will decrease. Meaning it will, suppose if you are on the earth, the pendulum will come down very quickly. I should not say suppose you are in Earth, we are on Earth. Okay. But suppose if you are in Moon, same pendulum, the gravity pull is very slow, which means it's going to come down very slowly, something like a slow motion. Okay. So my guess is it will be 6 times slower. 6 times, or sorry, root of 3, so it will be root of 6, so it will be 2.17. Okay. So it's something like twice. If this was coming down in 4 seconds, this will come down in 8 seconds. So it will be like a slow motion. T on the earth is 2 pi. They didn't talk anything about the length of the pendulum, so I'm going to leave it as L. G on the earth is 9.8. Now they are saying T on the moon. So what is asked? What is the time period of simple pendulum? So the formula is same, 2 pi square root of L by G. Length of the pendulum, you just took the same pendulum to the moon, so the length is same. But the G on the moon is less, 1.7. So I told you many times there is a simple method called equation 1 by equation 2. Whenever they give you two different information, and then ask you one of the things, you can simply divide this by this equation 1 by equation 2. So the time period in Earth is 3.5. So that means 3.5 divided by T moon. 2 pi cancels. Square root will not cancel. The square root will be there, but square root L and square root L will cancel. The 1.7 will go to the top. But don't forget the square root will be there. Do this math and we'll get the answer. So this one, I think it's approximately 6 times. Okay. So if you do the math, 1.7 into 6, so 42, 4. So 6 plus 4, 10, so 10.2. So it will be approximately 6 times, I think. So T moon is equal to root of 6, goes over here, so 3.5 into root of 6. Root of 6 will be 2 point something, so it will become 7 point, approximately more than 7. Okay. Because I know it's 2 point something, it's not 2. So what did I say at the beginning? Since the moon has got less gravity, the ball will be coming down very slowly. Okay. In the moon landing videos, you will see that people are kind of jumping and they don't fall as quickly as we do in the earth. So what that means is the moon is pulling you down very slowly, which means instead of taking 3.5 seconds, it will take 7 seconds or 8 seconds. So this is what I mean by even before you start the problem, based on the physics of the problem, you should expect what is the numbers I should be expecting. So I told I'm expecting 8 seconds. I got something around 7 seconds, which is close enough, more than 7. Copied? Anybody still copying? Okay, let's some water. Okay. So there are some theory type of questions. We can come back. Let's see. .17 is a pendulum inside a car moving on. I think I talked about this in the handbook. Let's see. A simple pendulum of length L having a bob of mass m is suspended in a car. The car is moving on a circular track of radius r. So that means there is a circular track like this. The car is taking a turn. So we are seeing the car from the top view. So the radius of the circular track is given as r, capital R. The uniform speed v. If the pendulum makes small oscillations in a radial direction means this is the radius, so it's in this way. So suppose if you are seeing it from the back, a car is like this, and then you have the two wheels like this, and then the pendulum is kind of hanging like this. Because this is your radial direction. What will be its time period? So if it was stationary, if the car was stationary, I could have easily said that time period is equal to 2 pi by omega. Omega is equal to root of L by G, sorry, G by L. So that means if I substitute this, I'll be getting 2 pi root of L by G. Okay. So if you're wondering, sir, where did we study this? Well, we studied this somewhere in this chapter over here, right? So I gave you this derivation. So omega is equal to square root of G by L. I do agree that, towards the end, we had to go a little bit faster. So go back and study all these things, take down your note, take your notes and look for, all these things. So you have different situations like this, which is important for your entrance exams. But as I always say, they don't give you much of a theory in the book, but they will ask you all the difficult questions in the numerical. So unless you understand all these things, you will not be able to solve this. So the problem which you are facing is this problem. Okay. So you have an accelerating vehicle. So since it is going in a constant speed, right? It is taking a circular motion. What do you think? Is it accelerating or not? If it is a constant speed, a circular motion. Is it accelerating or not?
It's accelerating, sir.
Why? But it's
Because
going at a
it's
constant speed.
constant speed, yeah.
So is it accelerating still? No answers. What did you say, Uzma? Is it accelerating or not accelerating? Simple
Not
question.
accelerating, sir.
Okay. Whenever there is a circular motion, what did we say? There is a centripetal force. When there is a centripetal force, is there a centripetal acceleration? The moment I confused you, right? You confuse yourself. So even though you are going in a constant speed, it is still accelerating. So take it down. This is the basics of circular motion. So since there is a force acting towards the center, which we call as centripetal force. This is coming from the friction between the road and the tire. Okay. Without this tire, what did we say? Without this friction, what did we say? This vehicle goes straight and hit this. Which means in order to make a circular turn, there must be a force acting, which means it is centripetal acceleration is also there. Do you agree, Uzma? Uzma, no answers.
Yes, sir.
So this is your AC. So we talked about centripetal acceleration and
Yes, sir.
tangential acceleration. So you see the gravity is pulling it downwards this way, and then the acceleration of on the pendulum is acting this way. Actually, the vehicle is pushing this way. The vehicle is trying to turn towards your left, which means you will get pushed towards the right. Why? Because you are a loose object. You are not attached to the car very rigidly. So that means the car will turn towards the left, whereas we will get pushed towards the right. Yeah, I'm sure all of you have experienced this when the car is taking a sudden turn. Okay. Have you experienced this, Mithun?
Yes.
Okay. So that means from the pendulum, right? If you see the pendulum, the gravity is acting downwards, whereas another acceleration which is acting this way. Okay, so this is AC. Towards the center means you would call it as centripetal. Away from the center means you would call it as centrifugal. So in reality, nobody is pushing you towards the right, but still, since the car is moving towards the left, your body is getting pushed towards the right. Okay. So I'm giving you an example of our human body. When we are sitting, I'm sure all of you have experiences. So same thing will happen for a loose object like a pendulum. So that means when the car is turning this way, it will experience a force system, which means the G is acting this way, the AC is acting this way, which means the resultant G, that's what I'm going to call as G effective. Remember, G is also an acceleration, this is also an acceleration, which means I can add apples with apples, oranges with oranges. Only thing I'm doing vector addition. Because this is a vector, this is a vector. Luckily, since it is 90 degrees, right? I can say G effective is equal to square root of G squared plus AC squared. So you see, for one single problem, you have to understand the centripetal force concepts from your fourth chapter. So coming back to this formula, T is equal to 2 pi square root of L by G effective. Why G effective? Earlier we had only G, now you have a G effective. So that means you should take the effective gravitation. G effective is nothing but AC squared plus G squared, or G squared plus AC squared. .17, so that's what I'm getting. But you know that since they are given the velocity and radius, I can say acceleration is equal to v squared by r. So that's one thing which I know. So 2 pi square root of this entire thing should be inside another square root, which you can write as 1 by 2. Any questions? Any doubts?
No, sir.
No, sir.
Okay. Again, this is documented there in your handbook, page number 37, I think 38. Okay, so I told you there are a lot of possibilities. They'll ask you questions in the entrance exams. Okay. For now, as I told you, at least the textbook you should be thorough. So you see, G effective is equal to G squared plus A squared, okay, because this is experiencing forces. Once I know G effective, I can simply substitute it in this formula. So T is equal to 2 pi square root of L by G of G effective. Okay, let's see. Some of the things I already discussed it in the theory, I believe. Okay. I think I did this cylindrical piece of cork of density. So when you float a cork and if you give a small tap on the on the top, right? If you tap it on the top, the cork will start going up and down. So that is also a simple harmonic motion. So I think we derived this. We talked about the YouTube, right? So all these things are there in this handbook. You see, this is your YouTube, this is your floating car. So I already discussed this. If you have any difficulties, please go through the theory and then come back and ask me, okay? Or send me a WhatsApp so we can discuss it in the following classes. Okay. Is that okay? Ashwant, Parthiban, Mithun Parthiban.
Yes.
So we already discussed these things. Okay, I discussed this one. Okay. A small ball inside a big container. So I discussed this one. So please go through it. When you try it and then when you break your head with it and then come back and ask the doubts, it will make more sense. Okay, instead of me keep on talking, you will get only say 50-60%. When you try it and then come back and ask clear your doubts, you will learn 100%. So go back and study the theory from your notes. So 18 and 19 I already completed in the theory. 20 also I completed in the theory, but it's all there in the handbook also. Okay, let's see. '21. You are writing it. So this is something to do with our damped oscillation. Okay. Can try some. 25. Okay, let's try the 21. I would say the additional exercises will be slightly difficult. Okay. Of course, these two things are also difficult. So as I told you at the beginning, try the easy ones first. Okay, then study the difficult ones. Definitely, the difficult ones will be there in your 5-mark questions. Okay. And the easy ones will be there for your 2 marks or 3 marks, whatever the pattern is. I do not know what's pattern for you. riding an automobile of mass 3000 kg, assuming that you are examining the oscillation characteristics of the suspension system. Suspension sags 15 centimeter when the entire automobile is placed on it. Sags means getting compressed, right? So that much of the spring is kind of getting compressed, that much. Also, the amplitude of the oscillation decreases by 50% during one complete oscillation. Estimate the values of the spring constant K, the damping constant B for the spring, and shock absorber system of 1B, assuming that each wheel supports 750 kg. So let's go back to our handbook. Let's capture the important formulas which we know. So you see, they said the amplitude is decreasing 50% in each oscillation. What does that mean? So we are talking about this graph. So here, if it was 100, here it is 50, here it is 25, here it is 12.5, then it is 6.25, something like that. So it keeps on decreasing. So since we are not talking about forced oscillation, we are talking about damped oscillation. Let me copy this and let's see if I can make use of these formulas. So we're supposed to find K, supposed to find B. What else? So K and B is supposed to be found. Angular frequency, they said suspension. Mass is given, M is given. Omega is suspension sags by 15 centimeters. So that means that is your something like your amplitude, I think. So decreases by 50%. So I know that this is decreasing by 50%. Okay, so since it is a spring system, I can use F is equal to Kx. So F is force applied 3000 kg into G, which is 9.8. So it means then they said each wheel is getting only 750, right? 3000 by 4 will give me 750. So it means 750 into G, approximately 10. K is what is asked. X, they said it is compressing by 15 centimeter, which means divide by 100 meters. So do the math, we get the K value. So how much will it be? Anyone quickly calculate this? This will be 3 times, this will be 2 times. 2 times 3 times, so it will become 25. 250 into 2 will give me 500. 500 into 100 will give me 500 into 100. So we're getting 50,000 Newton per meter. F by 6. Okay. Second part is where we may have to use this formula, because you see the amplitude is decreasing for every oscillation. They said that it is decreasing by 50%. How can I do this? Long T, long 2 I can use. So what we can do here is, they said that the amplitude is decreasing 50%. So that's a clue. So if the amplitude was here, after one oscillation, it has come down by 50%. After one more oscillation, it will come down by another 50%. Which means if this was amplitude, initial amplitude, this would be only half of A naught. This would be this divided by 2, so it will be A naught by 4. So I am going to take the distances between this point and this point. So that will be my one time oscillation. So that means that will be my time period, peak to peak. Okay, so that means I'm going to use this formula because this is your displacement. So displacement now here is only A naught by 2. Okay, so this is A naught and this is A naught by 2. Because this y-axis is nothing but displacement. How can I apply this? So when this displacement is equal to x of t, is your displacement as a function of time. So a into e power minus b by 2n. I'm going to ignore this cos. Why? Because we are talking about the amplitudes, means maximum point. So so whatever is in front of this cos, that is my amplitude. So that means after some time this amplitude becomes half. That means after some time this becomes A naught by 2. This is A naught. E power minus b by 2n into t. A naught cancels. I told you many times, whenever you see square root, if you don't like square root, what do? You square it on both sides. Similarly, whenever I see this exponential, I don't like this. So I have to take ln on both sides. Take ln 1 by 2. Ln and e will cancel. Ln and e will cancel. This term will come in the front. By the way, I said T is nothing but the time period T. So that means that is what is asked, I think. And ask T, but then I think I need to calculate, no, only if I calculate T, I can calculate the B. So I can write this as B by 2 into ms mass of the wheel, one wheel, which is 750 kg. B is also unknown. T is the time period, capital T. This minus, I'm going to take it on this side. Lot of mathematics. Okay, so we need to understand all these things. This minus will go to the top. One by 2 power minus 1. 1 by 2 power minus 1 is nothing but ln 2. I mean, this can be written as ln 2. 2 into 750 is 1500. Time period is nothing but 2 pi by omega. So how do I deal with this? I'm supposed to find, I already found the A part. So no issues. This is the A part. The B part is, I'm supposed to find the B. So I'm just trying to find some method. Let me try 2 pi by omega. This is very calculation intensive, I think. Okay. 2 pi by omega. But of course, that's the idea of advanced exercise. Okay. This is a little more advanced. So depending upon what is happening in your school, I would say definitely it's required for entrance exams, but for your school exams right now, depending upon whatever is taught in your school, make sure you are studying that thoroughly first. So B by 1500, 2 pi by omega. Omega I can write according to this, I can say square root of k by m times B by 2m. K is known, B is asked, 2m. So it means, so I think I should be writing k by m minus B by 2m. Ln 2 is 0.693. B by 1500. 2 pi by omega. So omega is square root of k by m minus B by 2m. You see, k is known. K is known, mass is known. B alone is not known. Here also B alone is not known, which means solve for K. Okay. Definitely not a easy one. Okay, you have to square it on both sides and then do some multiplications. Bring it here and there and solve for B. Write yourself. Okay, so the mathematics you can write yourself, and we can discuss it. I think you will be forming a quadratic equation. Once you form the quadratic equation, you have to use minus b plus or minus root of b squared minus 4ac by 2a. So take it down. The answer, according to your book, it's coming close to 1,300. Something close to 1,300 should be good enough. Okay, so make a side note. Something close to 1,300 you should get. So these things, try it yourself. Okay, if you try it and if you are not able to solve it, then I will help you in the next class. Waves is what I'm planning to get started in the next class. Okay. So I'll get started with the basic problems in waves. So in the meantime, you can try these things, okay, and then we can come for a second round. So if you have any difficulties, sir, I don't know how to start this problem means, we can discuss it in the next class. Okay. So try some of the problems, some easy problems from waves. Okay. So the basic exercise problems you can try it. Okay, thank you all. If you have any doubts, stay back. Otherwise, you are free to go. Thanks.